This video will illustrate a photovoltaic system, ad isola, also called standalone device. A group of students of Enzo Siciliano High School realized this project and assembled together all the components of the standalone device, coordinated by the teacher Professor Agostino Cardamone. The students also photographed all the steps during assembling stages, and we will show them to you in this video. We will shortly explain what is a standalone device and all the components needed to realize it. Standalone PV systems are usually installed in remote areas where there is no main grid, or it is difficult or even possible to use any other source of power supply. A PV system is said standalone device when it is not connected to grid public power and wherever a power grid is not at reasonable cost available, such as parking meters, emergency telephones, and traffic signs. Since the solar modules only produce electric energy during daytime, it is necessary to store energy for the night or for cloudy days. Such storage systems mostly use rechargeable batteries, therefore used to have energy available during cloudy days and during nights. The teacher is now adjusting the electric accumulator with a capacity of 100 ampere hours. We are seeing now the solar panel to install outside. It has a nominal power of 125 ampere hours and with an output DC of 7 ampere. In relation to the loads to be fed, all the necessary equipments will be connected. Battery regulator that prevents overcharging, electric panel with switches, circuit breakers, and the inverter to supply devices with AC voltages. The students are now linking the switches, circuit breakers inside the electrical panel. These circuits are used to link all devices and for electrical safety. In this image we can see the battery regulator with various power clamps. The first one is connected to the solar panel, the second one is linked with the accumulator, and the third to the power inverter to supply loads working with AC or DC current. This is the power inverter that supplies loads working with AC current. It's a 400 watt power inverter. They are now connecting an 11 watt lamp working with AC current. The students now are connecting a group of lamps, 12 volts each, working in DC, in a group of fans recycled from an old personal computer. Everything is ready. The electric panel link, power inverter, and battery regulator all connect. The lamp working with AC current and the group of lamps working with DC current. Now it's time to place the solar panel outside. This is the final step. Now it's time to bring the solar panel outside for irradiation to bring the accumulator in a state full charged. A topic moment, and I think a very important moment. The students locate and place the panel south-facing for maximum daily insolation. This is the connection between the solar panel with dedicated power clamps. After connecting the solar panel, here you can see the teacher verifying and measuring the output DC current. All done. Let's see if everything is working. These are the lamps working in DC current. Instead, this is the lamp working in AC current. Now we will try to turn on a computer connected to the system. Well done. Everything is okay. Thank you.